back to you. Probably going to skip mindfulness at the beginning just because we're already a little late. I did buy new pens. I did get a new stash. Well, that's not part of it. Look at that. It's better. Try that. And I got your written part of Sum 3. Claire, come on.
She's coming.
Oh, is she? Okay, that makes me happy.
That was a thank you if you could.
Oh,
segue.
yeah, cool, yeah. You're welcome. Adrian's not here. Shocked. Amanda. No. Nina. Hi. Oh, good you're here, Emma. I actually printed off your web work because we're going to talk about one of the problems you were having trouble with. So, the second one. No, it's good. I think it's good. Right? We're going to help you get it done. You did great. I'm really, first off, good job. You kicked butt on the web work so far. All right. Most welcome. Go on. New Alex. All right, that's good. If there's any questions on, everybody got it? Yeah, everybody's, okay, good. Claire's here, yay. So if there's any questions on what you got back, let me know. Happy to talk to you about that. Everybody did pretty good. I appreciate the effort put in. That really meant a lot. So. All right, I wanted to start off today addressing the web work that a few people have started. Then one person in particular, yes, you have started. You seemed very excited, Claire, so.
Oh.
No, that's cool, that's great. And I don't even care what it's about, so it just makes me happy. Actually, one person had progressed quite a bit in it, but was having trouble with problem 2. So I wanted to do an example like problem 2 so that when my friend Amma goes to finish her almost completed web work, she can easily do that. And the rest of you over this weekend, when you're like, wait, what were we talking about? Where was this? It's today, it's right now. So this is from the web work. And it is problem 2-ish. Let's take a little table here of some data points. And one thing to keep in mind while we're doing all of this stuff is this is like real life. When you're doing science of any kind, business science, chemistry, physics, whatever, when you're doing real science, you have data. You don't get a function. You get a bunch of observations taken over some time or just in different locations. So the stuff we're doing applies to real life. And it's going to build us up to something awesome. So we've got, let's see, t is 0, 2, 4, 6, 8. And then at those times, so I'm going to pick some different numbers here for sure. But let's get the right rhythm in here. Let's say that's 50, 45, 44, 20, and 15. The first thing I would do with this problem is draw it out. I would definitely make a picture of this and not extrapolate. In other words, add things that you don't know about. So just the raw data. So here's my time axis, here's my f of t axis. So at time 0, I've got 50. Remember, just put those dots. At time 2, I've got 45, so yeah, that looks okay. I put those numbers above them. for this type of process. It works out real good. At 4, we have 44, almost indistinguishable from the 45. At 6, I've got 20. It's about half that, right? A little under half. And then 15, which is 3/4 of that previous one. So right there. So that's 20, 15. Step 1, make a picture. Absolutely. And this will be a lot like yours. And I want to talk about some of this notation that's here, because we didn't really even get a chance to talk about it, and that's why I was hoping you would start and we could talk about it today. So I thank you, Amma, for this. So let's talk about what this process is about. So this is kind of like big picture here for a minute. And then we'll come back to our local picture, specific instance. So the big picture is this. I've got a function, and maybe I only know that function at some points, like in this case, but this is, let's say, f of x, and here's x. Just same thing as t and f of t, all good. And I've got a starting point and an ending point. So right now I'm just going to explain some of the notation you'll see in this problem, because otherwise it could be a little baffling. Oh, there's one. Good. Let me get this to you. I think, is that just, let's see, you only have 3, right? Yeah, cool. So the plan is this. I'm going to divide the interval a to b into n equal parts. So given n, which is our number of subintervals, divide the closed interval a to b into n equal parts. It's going to turn out that they don't need to be equal, but for the stuff in the web work, all good to go. But when we come in on Monday, I'm going to loosen this up a little bit and make it just n parts, n equal parts. So each part, each subinterval, apparently I don't know how to spell subinterval. Take your favorite. It probably doesn't have a hyphen in it. Subinterval will have length delta x. And so you'll see a delta t in this problem. This is what I'm talking about. How wide are these subintervals? So here's the first one, here's the next one, that's delta x there. And I go all the way across, and each one of these is delta x wide. And we've seen delta x before, just the change in x, nothing shocking. So the length is going to be the total length, and I want to explain this formula to you, divided by the number of pieces. Makes sense, right? If the whole thing is 1 mile long and I divide it into 10 parts, each part is 1/10 of a mile long. So that's all I'm saying here. And the general formula is going to be the right edge minus the left edge over n, the number of pieces. So let me let you kind of process that for a second. Let me grab some tea. Thanks for being here, by the way. I know it is challenging this time of year. It's challenging to just come here for these last couple of weeks because it's just time to fly, right? It's time to be in the sun, throw frisbees, have life soon. Way too soon, almost. Not too soon. It's gonna be good. Is there any questions on anything I've written up here? Is this making sense? You definitely want to be following along. So each subinterval will have this length. The subintervals also have endpoints. And the endpoints are going to be these points x0, x1, x2, on up to x sub n. And let me show you how I'm going to get those points. X sub 0, this is going to equal the left endpoint. And x sub n is going to equal the right endpoint. So we're going to start at the left edge, and we're going to tick by delta x units at a time. So the next one, so this is x0, the next one is x1. So notice that x1 is just x0 plus delta x. So I'm just adding a delta x to it, moving delta x to the right. x2 would be x1 plus delta x. Go to this point, add delta x. So on and so forth, and you just keep cruising through here and adding delta x. Next one's going to be x3, and that's just going to be delta x units away from the left point. So these points that I'm producing here, these are going to be my representative points. And in these problems, you're actually given that for the most part. Well, not, yeah, but we'll talk about it when we get there. Okay, so then the next step is going to be, so let's see here, plan. This plan's kind of big. Given these, do this. Let's give some numbers here. 1 is that. 2 is that, 3 is find those endpoints. Part 4 is use the value of the function at select endpoints, representative points. We don't, it might be left, it might be right, it's gonna, select is the key word here. And that's going to depend, that's going to change whether we have a lower estimate or an upper estimate. Just think about yesterday, we're using the left edge or the right edge, we got different answers. Use the value of f of x, these select endpoints, to determine the height of a rectangle above each subinterval. So what do we got here? I'm going to come through. Let's draw a picture. Again, the old function. Mine always looks like that. Boy, these, I hope this isn't my new batch, because they're pretty bad. Yes, that's what I pay the big bucks for. All right, yes. So here's A, here's B, and I'm going to literally do what I'm doing today like 3 times before the end of the semester, each time a little bit more rich and general. So here's x, here's x0, here's x1, here's x2, blah, blah, blah. Holy shit, it is nice to have good pens. Notice this one here is x sub n minus 1. So if this was like x sub 10, this would be x sub 9. Just kind of writing it in general. So let's say here, in this example, we're going to use the right endpoint. And so I go to each subinterval and I find the height of the function at the right endpoint. And I use that to determine the height. See this? Like so, and you can put dot, dot, dot in there. Those can be solid, and this can be solid. But if I use the right endpoints, it's going to look like this. If I use the left endpoints, let me just quickly put that up here in case you want that in your notes. Ooh boy. All right, there's A, there's B, and then here's x1, x2, x sub n minus 1, x sub n, x naught, dot, dot, dot. And so using the left endpoints, those rectangles are going to look very different. I mean, they're still gonna look like freaking rectangles, right? But they're gonna have different heights. And you can see here that that top one, just take a look. If we were thinking about area under that curve above the x-axis, top one's an overestimate, this one's an underestimate. And that should sync up with what we talked about on Wednesday, hopefully. And then what we're gonna do is add up all these areas. So let's write out what this is gonna look like. And this is taking us to something. So step 5 is add up the areas of the rectangles. And let me do that next to each one of these pictures and show you what that's going to look like. So here, the sum of the areas, and I'm introducing some notation, not actually new notation, but just an idea, I guess, really. Notice that this rectangle, let's put the heights above, is f at x1. This one's f at x2. This one's f at b, but we can call it x sub n as well. And it's going to help us to write it like that because now my sum of my rectangles is going to be, remember, it's just base times height for one rectangle. So this first one, I'm actually I'm going to write h times b, height times base. So this first rectangle has area f at x1 times delta x. Remember, each one of these is delta x base. Plus f at x2, delta x. Plus, cruise all the way down to the last one, f at x sub n, delta x. Can you write this one, please? Practice. What does that bottom sum look like? Just write the general flavor, the formula, like this one, but for left endpoints. After one more comment, we'll be pretty much ready to rock problem 2. It sets us up for some good chat for today. Bless you. Oh, whoop. Easy boy. And I imagine that last one could be potentially tricky. But it's just going to be height times delta x. And notice how it's really the same sum, just kind of shifted over. One, here we started at x1, ended at x sub n. Down here, we start at x sub 0 and end at x sub n minus 1. There we go. Questions at all how this works? We can write these in a pretty way because I'm going to take this and use some of the notation we talked about. So this one, notice how the thing that's moving is the index on the x. The only thing that changes from each part of the sum to the next is the subscript on x. So I'm going to write this as a sum, and I'm going to let I, and you can use any letter you want here. Classics are I, J, K, M, and N. You can use any letter you want, but in mathematics, like the culture of mathematics, these are the letters that are used in general for sums. So here, my first index is a 1, and it goes up to n. And then I write f of x of I, delta x. And now I'm going to ask you, can you write this one in summation notation now, please? what does that look like in that summation notation? I'm not a big fan of sigmas that don't have parallel, nice level tops and bottoms, so I don't like that sigma at all. I'm unhappy with it. Anybody help me out here? Kitra? Oh, sorry. Go ahead, Kitra.
Oh,
Sorry.
well, the I would go be a 1. Also, I hiccuped. That was.
Okay, yeah, exactly. And so the mathematical symbol for hiccup is that. Yes, and then where do we run up to?
And it would essentially be the same, except wouldn't you add a -1 to the I?
So I is going to run from 1, it's going to go, oh wait,
Oh,
this
I
should
meant
actually
in
start
the-
at 0, shouldn't it? Should, yes. Sorry, so I starts at 0 and then ends at n-1. So I guess that's
Okay.
what I was looking for there. And then this part is the same. It's just the range of x values changes. So it's just the starting index and the ending index that changes. Nita, was this what you were going to say? Yeah, cool. All right, this is called a Riemann sum. These are special forms of what are called Riemann sums. Riemann was an incredible mathematician in the late 1800s who did a lot of work with some other super famous people like, spelled his name wrong, Cauchy, Weierstrass, tons of them. This is post-Newton. This is post-Newton discovered, figured out calculus, or rediscovered calculus, and then these people cleaned it up and pushed it forward. All right, let's come back to problem 2. Problem at hand is this web work problem. So we're going through here, and let's see, I'll read it. In this problem, they give us these formulas. So now these formulas will hopefully make some sense when you get to problem 2 and you look at it. Was that a question, Olivia? No, that was just like a stretch. Okay, all right. And they give us this table. So in the first part, part A, they say use n equals 4 for subdivisions and fill in the following values. So they ask us to find delta t, which is the same as delta x, and that's just going to be right end minus left end over the number of cuts, 4. So delta t for this first part is 2. Here's delta t right here. And once I've got the delta t, the change in x or the change in the input variable, I can absolutely figure out all the endpoints. So the endpoints are just going to be, here's t sub 0. It's always the left end. Step over by delta t is 2. So t1 is equal to 2. And I don't think I need to write that because it's literally under the number 2. Here's t2, here's t3, and here's t4. Notice how there's one more point than there are cuts. It's just the way, cutting space works, I guess, really. So they ask us to label these in the next part of the problem, and then they ask us to find f at t0, f at t1, f at t2, and f at t3. And for this, I just have to grab the right values. So this one's going to be 50, 45, 44, and 20. And then the last thing I need to do is compute the left sum and the right sum. So you might want to, do some sketching if it helps you. The left sum is going to use the left end function value. So the left sum is going to be the sum of all these areas. And so here, left-hand sum is equal to height 50 times base 2 plus height 45 times base 2 plus height 44 times base 2 plus height 20 times base 2. Who cares what it is? It's not even a real problem, it's making it up, right? But you can do this and get that sum right. So that's the left-hand sum. What's the right-hand sum look like? Say that again?
50 times 0 plus 45 times 2.
So real quick, so it's starting to kick in good after the first part, but for the right-hand sum, let's look at the picture real quick. And actually, what you said is correct, but I just want to make sure. Of something. So the right-hand sum is going to look like this, right? Because I'm using the right end. So, and then this was 15 over here. So we don't need that 0 at the beginning, right? Does that make sense?
Yeah.
But it would have worked out okay. So what would it be on the?
45 times 2 plus 44 times 4 plus.
Now 4, always the base. 2
Times 2.
times 2. Yes, ma'am. Times 2, then what's next?
44 times 3.
Or 20. Yeah, whatever the hell that number is, right? Let's see, I think I said it was 20. And then plus 50 times 2. And that's it for that problem. And I think, yeah, that's, it's not quite it. Part C. Let's take a look at part C. It's gonna be all right. Part C is actually a little easier. In part C, they say n equals 2. And let's just take a minute. And I'm going to give you this. So repeat this problem, same data set, but use n equals 2. Give me the left-hand sum and the right-hand sum with n equals 2. So you're probably going to want to redraw that picture. You need new rectangles. You need a new delta t. If you can do this, you will undoubtedly rock the web work. And I think this is the tricky one on there. Just give you some sanity checks along the way. What are my t values going to be? What are my representative endpoints going to be? Yes, ma'am?
0, 4, and 8.
Beautiful. Does that make sense to everybody? That's perfectly right. Is that good, Diego? Not good?
No.
Okay, cool. So you cool with this delta t?
Yeah.
Awesome. So always going to start, t0 is always the left end of wherever I'm interested. And then I'm going to add this delta t to get to the next points. So this first one, t0, 0. That cool?
Yeah.
Yeah. Add 4 to that. So this is going to be my new base width right here. So I'm adding 4, add delta t. So t1 is equal to t0 plus delta t. And that's going to be 0 plus 4. And then the next one is just going to be 4 units away from that. So you just keep skipping by. Once you've got this set up, you just keep skipping that much.
Oh, okay.
Sound good?
Yeah.
Awesome. Really? Okay. I'll amuse myself with that for a second. Or 16. This one is 2, 6. That doesn't seem right. I don't think that's right. That can't possibly. 44 times 4. Good Lord, man. Get your shit together. 216. Why does that seem so odd to me that 44 times, that can't be. What am I doing wrong? Because 6, oh my God. Oh my God. That's what's wrong. Well, better take an Uber home. 376. Yeah, 376. Okay, good. Freaking A. And then 176 plus 60 is 236.
Yeah.
Okay.
So why didn't you do, on the left-hand side, why didn't you do 50 times 4 plus 44 times 4 instead of adding 15 as well?
Because, so let's check it, let's look, that's good. Ask these questions. So for the left-hand sum, so here's my points. Let's mark them off real big here. Right? So for the left-hand sum, I always use the value at the left end, So here I'm going to use 50 for that one. I'm ignoring all that stuff. I'm just going with the height at the left end. And then here at the left end, the height, well, I kind of did a bad job of it, but here the height's just 44 at that left end.
Oh.
Yeah?
Okay.
Yes?
Yeah.
Awesome. Awesome. And so then you see why I'm using with the right end. Olivia, is this feeling okay? Yeah, awesome, outstanding. And so, is it making sense on that right-hand sum now? Beautiful, beautiful. Cool. Any questions, anything to discuss here about this? Is feeling, we got this? We got this. Wonderful, my friends, wonderful. I think we'll just call it a day for me blabbing to you. If you want to stay, you don't have to, Claire. If you want to stay, I'll hang out here with you and you can finish the web work. Oh, okay, bye. So I will hang out here with anyone who wants that done. Remembering it's due Sunday night, 11:59 p.m. Split. Yeah, you could. You'll be fine. You'll be fine.